Welcome back to 3D Interactive Technologies. Effectively, the last video that we were looking at showed you how to fit a service manifold or gauge manifold onto your refrigeration system. What I want to do now is just to show you how to do your reclaim unit. So we've decided that there's a problem with this unit. For example, we could decide that the compressor, so maybe it's the compressor that's actually burned out and we're going to have to replace this compressor. In order to replace the compressor, we can't run the compressor and pump down the refrigerant into the receiver. There is no, on the discharge and suction side of this, or certainly on the discharge sides of this compressor, which is this side, there's no service access valves. So we're not able to isolate this compressor from refrigerant. So the first thing we have to do is recover all the refrigerant out of the system. Now what we're going to do is we're going to recover the refrigerant out into the bottle, we're going to carry out our repairs, and then we're going to use the same refrigerant and put it back into the system. So there's no need to, the refrigerant is good. Now, in a real circumstances, if you had a compressor that burnt out, what you'd have to do is you'd have to do an acid test on the oil, and you'd have to check the condition of the refrigerant itself. So if there was acid in the oil, then you probably more than likely would decide not to use the same refrigerant, and more than likely you'd have to make a judgment call and decide to send this off for the refrigerant that you reclaim into the recovery bottle. You'd have to send it off for destruction. Or you could decide that by using a couple of filter dryers, so small filter dryers here, if I was to fit a filter dryer on my hose going into the recovery unit and on my hose coming out of the recovery unit, I could do some form of cleaning and then decide to use it thereafter. But that again is down to a judgment call. If there is acid in your oil, when you do an acid test on your oil, then that means your refrigerant will be carrying traces of that. So putting a new compressor on would lead to the compressor possibly burning out before warranty of the replacement compressor. So probably advisable that if it's a compressor burnout because of an electrical burnout as opposed to a mechanical failure of the compressor, then it's probably advisable to use fresh refrigerant and to send the old refrigerant off for destruction. Now if you do send refrigerant for destruction, follow the regulations, make sure that you're pan registered with EPA, and make sure that you have a certificate of destruction from the place that you send your refrigerant back to be destroyed with, and that's just to cover yourself by law. So regardless of why we're taking the refrigerant out, I'm just going to, this is a short video just to show you how to connect everything up and how to make sure you're doing it within regulation. What we're using here is a standard recovery unit. Again, I'm not promoting any one product, it's just a recovery unit that I have here at the moment. What we can see here is that we have a suction side. Basically this short little hose here is just to stop any moisture or air getting into the actual job. So I'm just going to disconnect this hose here. So now we have our suction port and we have our discharge port. So this is the service port off my gauge manifold. So the yellow line is the service port off my gauge manifold, and I just put my gauge manifold onto the suction side. Okay. So basically now what's going to happen is the gas is going to be sucked in and discharged. So this is actually going to go onto the bottle. But before I put this onto the bottle, I need to check and make sure that there is enough capacity in this bottle. So we can see here that this bottle has written on it. So again, you know that this is a recovery bottle because it's yellow. It's marked as a recovery bottle. You can see there it's actually marked as a recovery bottle as well. And it tells you the max refill is 10 kg. So it's telling me maximum amount of refrigerant that I can put into this bottle is 10 kg. Okay. The other thing that you need to check is the tar weight. So we can see there the tar weight says 9.16 kg. So that's the weight of the bottle when it's completely empty, when it has no refrigerant in it. So if I put this down on the weighing scales, okay, you can see then from my weighing scales that the weight I have here is 10.31 kgs minus the 9.16 kgs. You do the maths, it tells you that I've about a kg of refrigerant in the system. Maximum that you can put into this, it says maximum is 10 kgs, but because this is refrigerant that's been circulating around the system and we really don't know the condition of that refrigerant, again, it's 60% of weight. So you might hear people talking about 80%, that's 80% of volume, so the total volume that can go into the bottle, or 60% of weight. So it's easier for us just to go by 60% of weight. So I would get 60% of my 10 kgs, which works out at about 6 kgs. So the maximum amount of refrigerant that I can put into this bottle is 6 kgs. And at the moment there's about 1 kg. So in other words, I have to just make sure that there's less than 5 kgs or there's a maximum of 5 kgs in this system. Now under normal F-gas rules, This bottle, if it isn't a virgin bottle, it's a brand new bottle. If it isn't a virgin bottle, it's a bottle that has existing refrigerant. There should be a label on this bottle. So the last person that used this bottle should have stuck a label on it saying what refrigerant was in it, how much refrigerant is in it, and what condition the refrigerant in. So it can either be reclaimed, recovered, or recycled. Now, if it's recycled, that means it was sent back to a factory. That means that there's a paper trail. It's traceable from the source that it came from to right back to where it was resold onto the market again. It also means that when it goes to factory, it is put through a cleaning process that brings it as near to virgin condition as is possible. Recovered means that we've just done recovered the refrigerant out of the system without doing any kind of cleansing, and reclaimed means then that we're using filter dryers or use some sort of filtration to try and clean it on site before we reuse the refrigerant. So recovered is fine for us from a point of view. We're going to recover the refrigerant and we're going to carry out our remedial repairs, and then we're going to reuse the refrigerant back into the same system again. Or if it's end of life and we're just recovering the refrigerant and we're going to use that in service somewhere else, that's acceptable as well, as long as it's within the refrigerant that can be used. So 404A, for example, is the refrigerant that we're using here, so you can use recovered 404A. But if it was one of the old refrigerants like R22, for example, you cannot use recovered R22. It must be destroyed. You cannot buy virgin R22. It's not available on the market anymore, and you cannot buy recycled R22. So if you come across a system that has R22 in it and it's come to its end of life, you must recover the refrigerant and send it off to be destroyed. You can't reuse it again. So, getting back to this job here, we know that it's safe for me to put more refrigerant in here because we've worked out our 60% by weight, and we've realised that there is capacity in this bottle. Second thing that I said to you, it should be labelled. If it's not labelled and you're not sure what refrigerant is in it, then you must do what's known as the pressure-temperature relationship. So that would literally involve me going along and putting a gauge onto the actual bottle itself, getting a thermometer, getting the temperature of the bottle, and checking to see is the pressure temperature relationship compatible. So in other words, that if the temperature of the bottle was 20 degrees, then I should be getting the compatible pressure for R404A. If it's not compatible with R404A, then we know then that this is not, there's a problem here. This is not pure refrigerant. So again, remember, I could bring out a slide rule, or I could take out the phone and I could use an app. But again, what we have is your gauge manifold acts as a pressure temperature slide rule as well. So we can see the black here represents bar. We can see the red represents the temperature in 404A, and the green line represents the temperature in 134A. So if I said that my bottle was 20 degrees, then I would go along here and I'd put 20 degrees, which is my my red hose here. So the red line is representing 404A. So there's your 10, 20, 30. So there's 20 degrees there. So if I was at 20 degrees there, the needle would be at 20 degrees there. The pressure that I expect in my bottle would be about 7.6 bar pressure. Okay, if it was at 20 degrees. But we're not going to do that because that's another video. We'll do that in a later video. Okay, so literally what we've done is we have got our service line from our manifold or gauge manifold, the service line in yellow, suction of the reclaim unit. Then we're going to put the discharge of the reclaim unit onto the bottle. Okay, now again, there is air in this service line here because it was open to atmosphere. There's air potentially in this recovery unit, and there's certainly air in this line here. So again, we need to be able to remove the air from the hose lines before we open the bottle. So we don't want to contaminate the refrigerant that's in the bottle, and we don't want to contaminate the refrigerant that's in the system with air. So before we do anything, you can see on our actual recovery unit, this valve is in the off position. That should say off underneath there. I know it's hard to see. If I turn it, you can see I'm going from off to vapor, and then if I turn it again, I go from vapor to liquid. Okay, so we always recover refrigerant. This is a recovery unit that's capable of taking liquid. We'll always recover 404A refrigerant in liquid. So any of the zeotropic blends, we try to recover and charge them in liquid. The azeotropic blends we can recover and charge in vapor, and actually recovering in liquid is probably faster than takes less time than actually trying to recover in vapor. But So we turn our valve to the liquid. Now what we need to do is we need to get the air out. So that just basically means that that valve is now open. That means that I can now get refrigerant into this hose here. So what I want to do is, on the vapor side, we're going to open my vapor. So remember, my manifold is closed at the moment. I'm still getting a pressure reading. My manifold valve is closed. If I open my manifold valve, right, refrigerant is going. You can hear it. So I just close that again, but you can hear it. The refrigerant is going from my yellow line, right? Remember, that's closed. It went along here. You can see where we have pressure here on my actual recovery unit. You can see we have pressure here on my recovery unit. That means that we have pressure at this point here. That means then that I can slightly crack this valve here. That's purging any potential air. Okay, so that purges any potential air that might be in those hose lines. So I'm now happy that I've purged out whatever air that's in it. Okay, next thing that I would do is I can now open my gas. Now the other thing that you will notice, and again this will come to light when we finish it, I have connected it to the vapor outlet of my bottle. And the reason why is because when I am finished the whole process, there will still be refrigerant inside in this line here. So I don't want liquid escaping off because it'll burn my hands, and under F-gas regulation, it's a no-go area to allow liquid to escape off the atmosphere. So literally this hose is kept as short as possible. So the shorter this hose, the better it is, because there's going to be a small trace of refrigerant left in this when we're finished. You can see here we have our purge on this particular type of unit, and that purge is basically for me to get whatever excess refrigerant remains in the recovery unit and excess refrigerant that remains in the lines when we get to the end of the recovery process. So before I switch it on or do anything else now, I'm just literally showing you this is how you connect your recovery unit to your system to be able to recover refrigerant. This is now being purged, so I've went through the purge steps. So now we're, as you've seen in the actual simulator as well, and you can practice in the simulator. But now that I've gone through the purge steps, it's safe for me to open this bottle here. The reason why I've deliberately connected to the vapor side of my bottle is because there's a valve stem in the vapor port which only goes down as far as the top of the bottle, which means that there's only vapor can ever enter into this actual valve itself. The liquid on the other side, the liquid valve, the liquid port itself has a valve stem that goes all the way down to the bottom of the actual bottle, and that means that it'll always pull liquid out of it. When it comes to the end of this process, when we're finished, you will see that at the very end I will put this valve to, when I've recovered all the refrigerant from the system, I will put this valve to purge and then switch the unit back on. That will purge all the refrigerant that's remaining inside in this recovery unit, all the refrigerant that's remaining inside in this surface hose back into the bottle. And when it finishes that process and all the refrigerant is emptied and in the bottle, I'll close off this valve. There will only be refrigerant left in this small line. We keep this line as short as possible because no matter what we do, there was always going to be a small trace of refrigerant left inside in this line. So you keep it as short as possible. You'll note that this is shorter than any of the other hose lines that we're using. And at the end of the process, when I go and take it off the bottle, it will only be vapor. If it was connected to my liquid port, at the end of the process, there would be liquid going everywhere, and that's a no-no. That would be an instant failure if you were going through your F-gas assessment, if you allow liquid to escape off the atmosphere. So we do not want liquid to escape off the atmosphere because of F-gas regulation and because of good practice from a health and safety point of view. Liquid refrigerant is at freezing temperature. It's going to burn my fingers. If it splashes into my eye, it'll burn my eye or whatever, or if it splashes onto my skin. And you'll notice that I'm wearing long sleeves when you're dealing with refrigerant, and you also would wear safety glasses as well. So before I do anything else, I check and I make sure that I have this small line from the discharge to my bottle on the vapor side of my bottle, and that's deliberately done even though I'm recovering liquid. Now before I start off the unit, what I want to do is I want to try and maximize the amount of refrigerant that I can get out of the system. So what I'm going to do is I'm just going to go over here and I'm going to open my liquid port, and by opening my liquid port you'll see refrigerant going through here. You will see this pressure rising, and we will actually be able to feel liquid refrigerant. So effectively what you try and do is you try and equalize the refrigerant that's in your system across and into your actual bottle, and when the two equalize, then we're in a position to switch it on. So I just leave that equalized there for a few minutes, and our next video that you'll see will be me switching on the unit and showing you how to carry out recovery. Thank you for watching 3D Interactive Learning Technologies, and I hope you subscribe to this channel, and we have lots more interesting videos to come.